and assembly costs are key goals in design for manufacturing and product development. So DFM focuses on designing products in a way that minimizes the cost of manufacturing, including the cost of individual parts, that is components, and the process required to assemble them. So by applying the principles of DFM, companies can achieve cost savings while maintaining product functionality, quality, and performance. So the strategies to reduce the component cost is first one is the standardization of components. So strategy, use the standard parts, components or materials that are readily available and used in multiple products. So benefit of this component is reduces the need for customer design parts, lowering costs due to economies of scale, easier sourcing, and lower inventory management cost. Example, using common faceless examples, screws, bolts, are off-the-shelf motors, bearings, and electronic components rather than custom parts. Second one is the material selection. So, what are all the strategies used for material selection are, so choose materials that are cost effective but still meet the product's functional, safety, and aesthetic requirements. So the main benefit of this method is the right material selection can significantly lower material cost while maintaining product performance. So using less expensive materials or materials that are readily available in large quantities can be more economical. Okay. So third one is the minimize part count. So reduce the number of parts by combining functions into fewer components or designing parts that serve multiple purposes. So the main benefit of this strategy is fewer parts lead to lower material cost, reduced assembly time, and less inventory management. So it can also reduce the likelihood of assembly errors. The fourth one is the design for efficient use of material. So design parts to minimize waste during manufacturing by considering material efficiency and optimizing the shape of parts. So reducing material waste reduces cost and helps with sustainability. So the fifth one is the optimizing the geometry and tolerances. So design parts with simpler geometries that are easier to manufacture and have more relaxed tolerances when possible. So complex geometries may require specialized manufacturing process or tight tolerances which can increase cost. By simplifying the design, we can reduce the need for expensive machining, casting or molding processes. So the next one is the design for multi-material use. So design parts that can use fewer or more common materials, thus reducing the overall cost. Multi-material designs can combine cost-effective materials where appropriate while ensuring the components function. Outsourcing or subcontracting the components. Outsource certain parts or components to specialized suppliers or manufacturers who can produce them more cost effectively. So this reduces in-house production costs and leverages the expertise of suppliers with economics of scale. So strategies in order to reduce the assembly cost are design for easy assembly, GFA. So it simplifies the assembly process by designing parts that are easy to handle, position and assemble. Reducing the complexity of assembly cuts down on labor time, errors and overall assembly cost. Reducing fasteners and hardware. Minimize or eliminate the need for fasteners, so that is screws, bolts, nuts and other hardware by designing parts that can snap together, interlock or be welded. So fasteners and hardware add cost due to their purchase price as well as the labor cost for handling, aligning and fastening them. Modular and simplified assembly. So design components and some sub-assemblies in modular form so that large sections of the product can be pre-assembled and tested before final assembly. Modular designs reduces the number of parts to be assembled during final assembly, speeding up the process and reducing the labor cost. Design for self-assembly. So it creates products that customers can easily assemble themselves or that can be assembled with minimal effort using simple tools. It eliminates the need for a specialized assembly workforce, reducing labor costs. Additionally, self-assembly often lowers packaging and shipping costs as products can be shipped flat. Reduction of handling and assembly time. Minimize the time and effort spent handling and moving parts during the assembly process. So this can be done by designing parts that are easier to orient, place and secure. Automating assembly process. So when where applicable, design the product so that it can be assembled with automation or robotics. Reducing the number of assembly operations. So simplify or combine assembly steps so that fewer operations are required during the assembly process. Each additional assembly operation adds cost in terms of labor time and machine time. So DFM driven design and cost estimation tools. First one is the DFM software tools. So tools such as DFM Pro, Autodesk, Fusion Lifecycle or Siemens NX offer integrated features to assess design for manufacturability, identify costly design elements and suggest alternative methods for cost reduction. Cost estimation softwares. So software tools like Costimeter or ProtoQuad allow manufacturers to estimate the cost of producing a component or product based on materials, the labor, tooling and other factors. So these tools help ensure cost-effective designs from the outset. So as a conclusion, in design for manufacturing, reducing component cost and assembly cost is achieved by simplifying the product design, selecting appropriate materials, minimizing part complexity and optimizing the manufacturing process. So a product that is easier to manufacture and assemble will not only reduce cost but also speed up the production, enhance product quality and improve competitiveness in the market. Thank you.